Okay, so almost after 8 to 10 days, we are meeting once again. So just I will brief you what we have seen in our last couple of lectures. So we have started with second unit, that is message passing. So this is the syllabus for message passing, and we have started with the definition of process. And then we have seen two types of inter-process communication, that is original sharing and copy sharing. So we have gone through the details of original sharing or shared data approach and copy sharing or message passing approach. Then we have gone through some desirable features of good message passing system. So from that them we have gone through the simplicity. So the features that we need for good message passing. So first is simplicity. Then we have gone through the uniform semantics. The semantics that we are going to follow in the local as well as the remote communication. Then efficiency, reliability, then correctness of your message that is passed, and then flexibility, security, and finally the portability. So these eight desirable features of good message passing we have seen in detail in the last lecture. So it is also told to you that one question can be asked on this particular bit, that is what are the different desirable features of good message passing system. So any four, or depending upon the marks, you can write your answer. Then we have seen the issues in IPC message passing system. So before that, or before proceeding to the issues in IPC message passing, we have seen the format or block diagram, or different blocks present in the message format. So hope you remember this diagram. So this particular part is a fixed length header, and this is the size variable size collection of typed data that which is having variable length. Okay, so these two parts, your message body will be divided into these two parts. So in this fixed length header, it is divided into mostly three parts, that is address, sequence number, and structural information. So address part, it is having both the receiver process address and sending process address. Both the senders and receivers process address will be there. Then sequence number is there. So each and every message is having its own message ID, so its detail will be present in this particular field. And then the structural information will be there, which is including the type of the message and number of bytes or elements present in that message. So type is nothing but the whether you are sharing any kind of link of the data, or it is actual data present in that. So that is present in that type. And number of bytes, so how much bytes will be consumed by this type, so that data will be present over here. And this variable size typed data, it is having the actual data. If you are sending the message like abcd up to z something, so that actual data will be there, or the pointer to the data. That means suppose you are sharing any file via link, so that link will be there in that, or just like a pointer will be there in the this particular portion, which is having variable size. Okay, so this way your message will be passed. Already we have seen the desirable features of good message passing, but here we are going to see the issues. While doing this message passing, what are the different issues that we are facing? So that issues are, these are listed over here. So who is the sender, whether that sender is authorized person or not. If it is not or if that person is not an authorized person, then you should not accept that message. Then again, who is the receiver? Whatever the receiver is there, whether that person is also authorized one, accordingly that message will be sent. Then, is there one receiver or many receivers? So if you are going for point to point communication, or broadcasting your message or multicasting your message, depending on upon the situation, this will be come into picture. Then, is the message guaranteed to have been accepted by its receiver? So if I am sending the message but it is guaranteedly accepted by the receiver, um, or if in between some hackers may attack on your system, then whether it will be hacked by the hackers, so that will be that also we have to consider. Then next, does the sender need to wait for a reply? So if any kind of acknowledgement is there from the receiver side to the sender, and then after that particular notification only sender has to send the data. So that type of scenario will be there. Then what should be done if a catastrophic event such as node crash or communication link failure occurs during the course of communication? So suppose such kind of situations happens कि your communication links get failed or your node is getting crashed. So what will be the action taken for such kind of situations? Then what should be done if the receiver is not ready to accept the message? Okay. So suppose a receiver is not accepting that particular message, then whether that message will be discarded or stored in the buffer, or in the case of buffering, what should be done if the buffer is full? So accordingly we have to pass our message to the respective solution. That means whether it will be discarded or stored in the buffer, and if stored in the buffer, what should be the size of your buffer in case if it is full? So after buffer full, what will be the condition with my message? So all these scenarios we have to consider and give proper solution to all these conditions. Then, if there are several outstanding messages for a receiver, can it choose the order in which to service the outstanding messages? Means for which particular messages I have to give the priority, and highest priority, and to give the lowest priority, that will be decided by the receiver or sender itself, and how the processing will be done. Or if the message as they are coming in that way only, means first come first serve basis only, they will be given, or in that manner only they are reaching to the receiver. So that we have to consider over here. So these are all the around 8 issues we have to go through in our message passing system. So till this point we have seen uh, the things in the last lecture. So next bit is our synchronization. Okay. So synchronization, the semantics used for synchronization are broadly classified as a blocking and unblocking, sorry, non-blocking types. So your synchronization process, these are divided into two parts, blocking and non-blocking. So till now there is no question on this particular thing, like differentiate between blocking and non-blocking. But to remember this point properly, I have made it in two columns. So blocking time type, what does it mean? So it is invocation Invocation may block the execution of the invoker in case of blocking, and in case of non-blocking, the invocation does not block the execution of its invoker. So the control returns almost immediately to the invoker. तर यामध्ये नेमकं सिनारिओ कसा आहे तो आपण नेक्स्ट याच्या पुढच्या बिटमध्ये पण पाहणार आहोत. So invoker means what? Here we are considering it as a sender. So whether the sender, after sending his message, whether he is blocked for some reason, like he will be in waiting position to get the acknowledgement, or he is not at all blocked. So depending on the situation, it will be divided into blocking or non-blocking type. Then in case of blocking, send primitive, after execution of the send statement, the sending process is blocked until it receives an acknowledgement from the receiver that the message has been received. आत्ताच सांगितलं त्या पद्धतीनं सेंडरनी मेसेज सेंड केलेला आहे, तर हे एक्झिक्युशन झाल्यानंतर सेंडरला काही वेळासाठी एक्नॉलेजमेंटसाठी थांबावं लागणार आहे का? Whether he is required to wait for some time to get the acknowledgement. If it is allowing for waiting for acknowledgement, then it is coming into the blocking type. Else, for non-blocking send primitive, after execution of the send statement, the sending process is allowed to proceed with its execution as soon as the message has been copied to a buffer. म्हणजे या केसमध्ये तुमचा मेसेज जो आहे तो एकदा बफर मध्ये पडला की त्यानंतर तुमचा सेंडर पुढचं काही त्याचे काही मेसेज सेंडिंगचं टास्क असेल किंवा त्याचं जे काही टास्क असेल तर ते सगळं करण्यासाठी तो रिकामा. So this is the scenario in case of non-blocking. Then again, in case of blocking, in the case of blocking, receive primitive, after execution of the receive statement, the receiving process is blocked until it receives the message. So here in this case, first scenario we have seen while sending the message or from the sending primitive. Then in case of receive primitive, so after execution of the receive statement, the receiving process is blocked until it receives the message. जोपर्यंत त्याला मेसेज पूर्णपणे रिसीव्ह होत नाही तोपर्यंत रिसिव्हर सुद्धा ब्लॉक्ड स्टेट मध्ये जाणार आहे. बट हिअर इन केस ऑफ नॉन ब्लॉकिंग रिसीव्ह प्रिमिटिव्ह, द रिसिविंग process proceeds with its execution after execution of the receive statement, which returns control almost immediately just after telling the kernel whether the message buffer is full. जोपर्यंत तुमचा मेसेज बफर फुल होत नाही तोपर्यंत रिसिव्हिंगची जी काही प्रोसेस आहे ती त्याची कंटिन्युअसली चालूच राहणार आहे. सो दिस इज द blocking and non-blocking scenario in case of synchronization. Then an important issue in non-blocking receive primitive is how the receiving process knows that the message has been arrived in the message buffer. Okay, so काहीतरी मेसेज सेंडरनी सेंड केलेला आहे आणि तो मेसेज बफर मध्ये येऊन पडलेला आहे, हे रिसिव्हरला कशा पद्धतीने कळणार आहे? तर त्यासाठी देर आर टू टेक्निक्स. In that, the first is polling. So in this method, a test primitive is provided to allow the receiver to check the buffer status. The receiver uses this particular primitive to periodically poll the kernel to check if the message is already available in the buffer. जसं की आपण करतो पोलिंग, प्रत्येक वेळेला काही काही टाइम इंटरवल नंतर आपण मेसेजेस चेक करत जातो व्हॉट्सअपचे वगैरे. तर दिस इज नथिंग बट द पोलिंग. एक 10 मिनिटांच्या इंटरवल नंतर 15 मिनिटाच्या इंटरवल नंतर आपण चेक करत जातो व्हॉट इज द स्टेटस ऑफ माय व्हॉट्सअप. If messages are there, I will be diverted to that particular sender of the message. Okay, So this technique is called as a polling. And the second technique is interrupt. So in this method, when the message has been filled in the buffer and is ready for use by the receiver, a software interrupt is used to notify the receiving process. Software interrupt means you have to program this particular send receive primitive in such a way that after getting the message it will call some kind of interrupt म्हणजेच काय की एक अशी सिच्युएशन की त्यामध्ये काही ऑपरेशन्स तुमचे स्टक होतील, वेट करतील अदर ऑपरेशन्स परफॉर्म होण्यासाठी. So this method permits the receiving process to continue with its execution without having to issue unsuccessful test requests. Although this method is highly efficient and allows maximum parallelism, its main drawback is that user level interrupts make programming difficult. या केसमध्ये जे काही इंटरप्ट्स जनरेट करण्याचं काम आहे की बाबा मेसेज सेंड झालेला आहे, रिसिव्ह झालेला आहे, त्यानंतर काही वेळासाठी मला थांबायचं आहे, पुन्हा काही वेळानंतर मी नवीन अजून मेसेज चेक करणार आहे, आणि या प्रत्येक ऍक्टिव्हिटीमध्ये काय होणार आहे, इंटरप्ट्स तुम्हाला जनरेट करायचे. सपोज मी एक मेसेज सेंड केला तर त्यानंतर त्या मेसेजचं काम कम्प्लीट होईपर्यंत किंवा त्याचं प्रोसेसिंग कम्प्लीट होईपर्यंत माझ्याकडे दुसरा मेसेज येता कामा नये. सो तशा टाईपचं जे काही प्रोग्रामिंग आहे इंटरप्ट जनरेट करून, तर ते तुम्हाला सॉफ्टवेअर थ्रू करावं लागणार आहे. अँड दिस काइंड ऑफ user level interrupts hard coding is a bit difficult task. So these are the two techniques for checking the received or arrived messages in your message buffer. Then again, synchronization continued. So when both the send and receive primitives of the communication between two processes use blocking semantics, the communication is said to be asynchronous. Otherwise, it is synchronous. Otherwise, it is asynchronous. That is, for synchronous communication, the sender and the receiver must be synchronized to exchange a message. This is illustrated in the figure. So hope all of you are able to view this particular figure. So in this figure, this left side gives you the sender's execution and right side gives you the receiver's execution. So here, before receiving the message, your receiver will be in blocked state. Whatever the dotted lines are shown, those are blocked states, and continuous lines are showing you the executing state. Okay, so before getting the message from the sender, your receiver will be in the blocked state. So here it is shown in the dotted form. Now your sender will send the message. Okay, so it is shown in this particular with this arrow. It is showing that your message is sent to the receiver. Okay, so after this message will be received to the receiver, its execution will start or resumed, and then he will send the acknowledgement that he has received the message. So this acknowledge will be sent back to the sender, and then the continuation will be done. So in this particular period, that is from sending the message to receiving the acknowledgement, this period from the sender side is in blocked state. Okay, so keep in mind, while showing this particular diagram, you have to show this particular field, that is before accepting the message at the side of receiver, you have to show it by dotted lines, and then after sending the message up to receiving the acknowledgement, the sender's side will be in the blocked state. Getting the concept? So this diagram is um, totally showing you the way of communication, that is synchronized way of communication. uh, Examples we have discussed last time, that is, say for example, in case of टेलिफोनिक कन्व्हर्सेशन मध्ये तुम्ही डायरेक्टली नुसतं हाय हॅलो कसे आहे जेवले का असं डायरेक्टली तुम्ही 5-6 प्रश्नांचा भडीमार करता का? नाही. सपोज मी हॅलो म्हटली तर आय विल वेट फॉर सम टाइम टू माय रिसिव्हर शुड गिव्ह मी द एक्नॉलेजमेंट बाय सेइंग बॅक हॅलो. सो मी काय म्हणणार मग नंतर, जेवले का? तर त्यांच्याकडून परत मला रिप्लाय येईल हो किंवा नाही वगैरे वगैरे. पुन्हा माझा नेक्स्ट क्वेश्चन जाईल. ओके, सो आय विल बी वेटिंग फॉर द एक्नॉलेजमेंट. आता टेलिफोनिक कन्व्हर्सेशन मध्ये मी काय म्हणणार की आन्सर, मी प्रश्न विचारते म्हणजे मी काय करते, आन्सर साठी वेट करते रिसिव्हर कडून. बट नो मॅटर ऑलवेज इट विल बी लाईक दॅट ओनली. ओके, हे कम्युनिकेशन तुम्ही अजून दुसरं काही एक्झाम्पल असंही कन्सिडर करू शकता की तुम्ही गुगलला काहीतरी क्वेरी टाकली आहे. ओके, काहीतरी इन्फॉर्मेशन पाहिजे तुम्हाला, तर क्वेरी टाकल्यानंतर तुम्हाला लगेचच इन फ्रॅक्शन ऑफ सेकंड्स यू आर गेटिंग द रिप्लाय. पण ते सगळं होईपर्यंत तुम्ही लगेच आता जर नेटवर्क तुमचं अगदीच स्लो असेल, आताच्या कंडिशनला असं नाही पाहायला मिळत आपल्याला की नेटवर्क खूप स्लो आहे आणि गुगलवरती एक काहीतरी क्वेरी टाकली आहे आणि तुम्हाला तोपर्यंत तुम्ही तुमचा दुसरा काहीतरी टास्क करताय वगैरे वगैरे, असं आत्ताच्या कंडिशन किंवा आताच्या आपलं जे काही नेटवर्किंग आहे किंवा जे काही स्पीड आपल्याला मिळते, तर त्याच्यामध्ये आपल्याला ही सिच्युएशन नाही बघायला मिळत. क्वेरी टाकली की इन फ्रॅक्शन ऑफ सेकंड्स ओनली यू विल बी गेटिंग द रिप्लाय. ओके, जेव्हा आम्ही कॉलेजमध्ये होतो तेव्हा आमची कंडिशन अशी असायची की गुगलला आम्ही काहीतरी क्वेरी टाकायचो, त्याचा रिप्लाय येईपर्यंत मग तुमचं काहीतरी कोडिंग असेल तर हे ट्राय कर ते ट्राय कर सोल्युशन साठी वगैरे, किंवा दुसरं काहीतरी आपलं राईटअपचं काम असेल तर ते करत बसणे. मग थोडंसं 2-3 मिनिटांनी मग रिप्लाय वालं पहिलं पेज येणार. मग त्यानंतर जे काही रिझल्ट मिळालेले आहेत त्यातल्या लिंक्स, पुन्हा हायपर लिंक्स ज्या आहेत, तिथून पुढे प्रोसीड करायचं असेल तर एक लिंक टाईप करायची, पुन्हा 2 मिनिटं वेट करायचं. अशा पद्धतीची आमची कंडिशन असायची. तर तसं आता नाहीये. सो त्या कंडिशनमध्ये तुम्ही काहीतरी क्वेरी टाकली, होल्ड करा, वेट फॉर एक्नॉलेजमेंट अँड देन यू कॅन स्टार्ट युअर ओन एक्झिक्युशन, राईट? सो दिस इज द synchronous way of communication. So conceptually, the sending process sends a message to the receiving process, um, then waits for an acknowledgement. So after executing the receive statement, the receiver remains in blocked condition until it receives the message sent by the sender. On receiving the message, the receiver sends an acknowledgement message to the sender, and the sender resumes its execution only after receiving this acknowledgement message. So आता जे काही डायग्राम मध्ये बघितलं तेच या 4 ओळींमध्ये आपल्याला डिस्क्राईब करून सांगितलेलं आहे. So this is the point of synchronization. Do you have any doubt in this? Okay. So next bit is buffering. Messages can be transmitted from one process to another by copying the body of the message from the address space of the sending process to the address space of the receiving process. Okay, this way the message transmission takes place. So process possibly via the address space of the kernels of the sending and receiving computers. Okay. So in some cases, the receiving process may not be ready to receive the message transmitted to it, but it waits for the operating system to save that message for later reception. Later reception. Okay. So for this kind of situation, you have to store your messages at some place. So in these cases, the operating system will rely on the receiver having a buffer in which messages can be stored prior to the receiving process executing the specific code to receive the message. And that space is nothing but the buffer. So in inter-process communication, the message buffering strategy is strongly related to synchronization strategy. The synchronous and asynchronous modes of communication correspond respectively to two extreme buffering, that is a null buffer or no buffering, and a buffer with unbounded capacity. So this is the case in case of um, synchronous, and other two commonly used buffering strategies are single message and finite bound or multiple message buffers. So it is in case of asynchronous. So these four types of buffering strategies we are going to discuss now. After these, the first is the null buffer or no buffering. So in case of no buffering, there is no place to temporarily store the message. Hence, one of the following implementation strategies may be used. So the first is the message remains in the sender process address space and the execution of the send is delayed until the receiver executes the corresponding receive. And the second way will be the message is simply discarded and the timeout mechanism is used to resend the message after a timeout period. So first strategy is the message will remain in the sender's process address space and the execution of the send is delayed, okay, until the receiver executes the corresponding receive message for this. And the second is the message is simply discarded and the timeout mechanism is used to resend the message after timeout period. So in these two ways, your no buffering or null buffer will be working. No buffer means what? Ki you are not having any kind of buffer. Just sender is sending the data directly to the receiver. आणि हे इम्प्लिमेंटेशन करत असताना आपली कंडिशन काय आहे किंवा स्ट्रॅटेजी काय असणार आहे, तर त्यामधली पहिली स्ट्रॅटेजी अशी असणार की सेंडर प्रोसेस जो आहे दॅट विल सेंड हिज मेसेज अँड रिसिव्हर कडून जर तो रिसिव्ह झाला प्रॉपरली म्हणजे ऑन टाइम वगैरे, तर तुमचं मेसेज सेंडिंग पास होईल. अदरवाईज द मेसेज विल सिम्पली बी डिस्कार्डेड और यू कॅन इन्सर्ट द टाइम आउट्स इन बिटवीन. सो एका पर्टिक्युलर टाइम नंतर सपोज एक 10 सेकंद 15 सेकंदाचा टाइम दिला तर तो टाइम आउट झाल्यानंतर डायरेक्टली तुमचा मेसेज डिस्कार्ड होईल. या दोन वेजनी तुम्हाला नल बफर इम्प्लिमेंट करायचा. So as shown in the figure, in this case, in case of no buffering, the logical path of message transfer is directly from the sender's address space to the receiver's address space, involving a single copy of operation. म्हणजे इथून जो काही तुमचा मेसेज आहे तर त्यामधून डायरेक्टली तुमचा मेसेज हा रिसिव्हिंग प्रोसेसला जाणार आहे. इन बिटवीन याच्यामध्ये कुठलंही चॅनल किंवा काहीही असणार नाहीये. डायरेक्टली सेंडर टू रिसिव्हर मेसेज ट्रान्सफर विल बी टेक प्लेस. So this is the first technique. Second is single message buffer. So second technique case मध्ये single message buffer. So the null buffer strategy. जी नल बफर स्ट्रॅटेजी आपण बघितली तर त्याचे ड्रॉबॅक्स काय आहेत. सो नल बफर स्ट्रॅटेजी इज जनरली नॉट सुटेबल फॉर सिंक्रोनस कम्युनिकेशन बिटवीन द टू प्रोसेसेस. यामध्ये काय होत आहे, टाइम आउट पिरियड नंतर म्हणजे कुठल्याही प्रकारची एक्नॉलेजमेंट वगैरे आपण वेट नाही करत आहे त्याच्यासाठी. टाइम आउट झाला की डायरेक्टली तुमचा मेसेज त्यामध्ये डिस्कार्ड होतोय. बरोबर आहे. सो इफ यू आर डीलिंग विथ synchronous type of communication between the two process, then if the receiver is not ready, a message has to be transferred two or more times, and the receiver of the message has to wait for the entire time taken to transfer the message across the network. सो जर इन केस तुमचा रिसिव्हर फ्री नसेल किंवा त्याच्या साईडला काहीतरी प्रॉब्लेम असेल तर प्रत्येक वेळेला जेव्हा जेव्हा तुम्हाला टाइम आउट मिळणार आहे त्या प्रत्येक वेळेपर्यंत तुम्हाला मेसेज रिपीटेडली सेंड करावा लागणार आहे नेटवर्कवरती. बरोबर आहे. सो in distributed system, message transfer across the network may require significant time in some cases. So therefore, instead of using the null buffer strategy, synchronous communication mechanism in the network or distributed system use a single message buffer strategy. सो अशा पद्धतीनं जे तुम्ही टाइम मेसेजेस सेंड करताय तर कंटिन्युअसली तेच मेसेजेस सेंड करण्यापेक्षा न्यू स्ट्रॅटेजी इज देअर अँड दॅट इज सिंगल मेसेज बफर. So the diagram itself will show us the structure of our buffer in which there is a place of one message or it is called as a single message buffer. So in this strategy, a buffer having capacity to store a single message is used on receiver's node. This is because in system based on synchronous communication, an application module may have at most one message outstanding at the time. So the main idea behind single message buffer strategy is to keep the message ready for use at the location of the receiver. सो जो काही बफर आहे तुमचा त्याचं स्ट्रक्चर कुठे आहे तुमचा रिसिव्हर साइडला. हिअर इज द नोड बाउंड्री. ओके, दिस डॉटेड लाईन इज शोइंग यू द नोड बाउंड्री वेअर this side is for senders and for receiver side you are having your buffer situated. Therefore, in this method, the request message is buffered on the receiver's node if the receiver is not ready to receive the message. The message buffer may either be located in the kernel's address space or in the receiver process address space. So as shown in the figure, in this case, the logical path of the message transfer involves टू कॉपी ऑपरेशन. म्हणजे तुम्ही एकदा कॉपी केल्यानंतर मेसेज तुमचा बफर मध्ये जाऊन पडेल आणि त्यानंतर तिथून तो कॉपी कुठे होणार आहे रिसिव्हर प्रोसेसला. ओके, गेटिंग द कन्सेप्ट. सो हिअर देअर इज द बफर ऑफ ओनली वन मेसेज ॲट अ टाइम. Then the next part is unbounded capacity buffer. So in the asynchronous mode of communications, Since a sender does not wait for the receiver to be ready, there may be several pending messages that have not yet been accepted by the receiver. आता रिसिव्हरच्या साईडला जर मल्टिपल त्याला मेसेजेस ॲट अ टाइम मिळाले तर त्यानं कुठलं पर्टिक्युलर ॲक्सेप्ट करायचा, दॅट विल बी द चॉईस ऑफ रिसिव्हर ओनली. So he will be having lots of pending messages over there. So therefore, an unbounded capacity message buffer that can store all unreceived messages is needed to support asynchronous communication with the assurance that all the messages sent to the receiver will be delivered. So या केसमध्ये तुम्हाला ॲश्युरिटी द्यावी लागेल की युअर सेंट मेसेजेस, ऑल द सेंट messages are delivered to the receiver. So this is nothing but the unbounded capacity buffer, but it is in practice it is hard to implement because unbounded म्हणजेच काय, तुम्ही जर लिस्ट स्ट्रक्चर वापरत असाल तर लिस्टमध्ये किती नंबर ऑफ नोड्स असायला हवेत हे तुम्ही आधी जर डिसाईड केलं असेल किंवा माझ्या लिस्टमध्ये एक 10 नोड असायला पाहिजेत वगैरे वगैरे, तर ते झालं बाउंडेड. पण जर जशा रिक्वेस्ट येतात तसे मल्टिपल तुम्ही ऍड करत गेला तर त्याला किती लिमिट असावं, 10, 50, 100. अनबाउंडेड असेल तर ते प्रॅक्टिकली त्याचं इम्प्लिमेंटेशन करताना इट विल बी डिफिकल्ट. So we are having the next type, that is finite bound or multiple message buffer. So just check the figure over here. So here you will be having the sending process. Here for the multiple message buffer or mailbox or port, you will be having the structure of first come first serve. Means whatever the message you are sending, it will be stored in the buffer, multiple message buffer, and whichever message that is coming first, that will be going out to the receiver side first. So whatever the message is coming first, that will be served first. So first come first serve basis. On this basis, your message operation will be taking place. So unbounded capacity of a buffer is practically impossible. Therefore, in practice, systems using asynchronous mode of communication use finite bound buffers, also known as multiple message buffers. When the buffer has finite bound, a strategy is also needed for handling the problems of a possible buffer overflow. सो या केसमध्ये जर बफर आताच्या डायग्राम मध्ये दाखवलं त्या पद्धतीनं जर बफर तुमचा काहीतरी से 50 नंबर ऑफ मेसेजेस ऍक्सेप्ट करत असेल तर व्हॉट विल बी द पिक्चर आफ्टर दीज 50 मेसेजेस, व्हॉट विल बी द सिच्युएशन इफ युअर बफर इज गेटिंग ओव्हरफ्लो. सो द बफर ओव्हरफ्लो प्रॉब्लेम कॅन बी डेल्ट विथ one of the following two ways. There are two ways for this. First is unsuccessful communication. So in this method, message transfers simply fail whenever there is no more buffer space. The send normally returns an error message to the sending process, indicating that the message could be delivered to the receiver because the buffer is full. And unfortunately, the use of this method makes message passing less reliable. So unsuccessful communication च्या केसमध्ये जर माझा बफर फुल होत असेल तर त्यानंतरचे मेसेजेस तुमचे बफरमध्ये ऍक्सेप्ट केले जाणार नाही, ते सगळे तुमचे डिस्कार्ड होतील. तर त्या केसमध्ये हे जे काही डिस्कार्डेड मेसेज आहेत त्यांचं पुढं काय होणार आहे, वेदर दे आर रिचिंग टू द हॅकर्स किंवा अशा पद्धतीनं जर रिलायबिलिटी तुम्हाला तुमच्या या सिस्टीमला किंवा बफरला देता आले नाही, then this particular unsuccessful communication in case of finite bound will be less reliable. So this is first way, and second is flow controlled communication. So the second method is to use flow control, which means that the sender is blocked until the receiver accepts some of the messages, thus creating space in the buffer for new messages. म्हणजे काय होईल, सेंडर जो आहे तो जसं जर सपोज कंटिन्युअसली त्याने एक 10 मेसेजेस सेंड केले, तर त्यानंतर अशा पद्धतीने प्रोग्राम करायचा की ही विल वेट फॉर सम टाइम टू सेंड हिज नेक्स्ट मेसेज. सो काय होईल, इन बिटवीन पिरियड मध्ये काय होणार आहे की रिसिव्हर जे काही मेसेज ऍक्सेप्ट करणार आहे तर ते ऍक्सेप्ट केल्यानंतर तुमच्या बफरमध्ये काहीतरी स्पेस होईल आणि त्यानंतर पुन्हा सेंडर कडून नवीन मेसेजेस तुमच्या बफरमध्ये ऍड होतील. सो दिस मेथड इंट्रोड्युसेस अ सिंक्रोनायझेशन between the sender and the receiver and may result in unexpected deadlocks. So या कंडिशन मध्ये मे बी डेडलॉक्स मे अराइज, कारण सेंडर तुमचा वेट करतो आहे की बाबा बफर त्याचा एम्प्टी व्हावा, पण रिसिव्हर जर आहे तर त्याचं वर्किंग अजून चालूच आहे की किंवा त्याचा स्पीड कमी पडला नवीन मेसेजेस ऍक्सेप्ट करताना, तर या सेंड अँड रिसीव्ह मध्ये काही ब्लॉकेजेस किंवा डेडलॉक कंडिशन्स अराइज होण्याची शक्यता आहे. ओके, सो मोर ओव्हर ड्यू टू synchronization imposed, the asynchronous send does not operate in the truly asynchronous mode for all the send commands. So these are the 4 types of buffering. Any doubt till this point? Still, if you have any kind of doubt, you can put it in the chat window, or else just put your attendance in the chat with your name. I will be winding up the session now only because because of the cough problem, and some kind of I'm not feeling well, so we are having our scheduled lecture tomorrow as well. Okay, so put your attendance and you can leave the session